Today we have a simple kit. Let's just open it up and have a look. There's no instructions with this, and actually I can't remember where I got it from. So this is called a multivibrator. So it's basically got two transistors as switches. It's got a couple of LEDs that are going to flash. Capacitors here and 4 resistors, and quite a nice little printed circuit board to put it on. So multivibrator is a 2-switch flasher, or it can be a square wave generator, but in this case it's got some LEDs, so it's gonna flash, and so the LEDs are gonna alternately flash. And this was kind of a standard circuit that we used to build quite a lot back in the 70s, 80s, when there were a number of different electronics magazines. So it's a quite simple circuit you can build. You can do it with a breadboard or a piece of Vera board. It doesn't need a printed circuit board, but this is a bonus. So let me quickly reverse engineer that, because we don't have a schematic to follow, and then I can confirm what I think it is. So I took a couple of photographs of the front and the back, so I could figure out what was linked to what. And yeah, just as I thought, it is a multivibrator. So this is the circuit. So what I'll do, I'll build it up. I'll get my soldering iron switched on and put all the components in, and then I'll go back and I'll explain how it works. First of all, I'll fit the resistors. So on the circuit board it's marked 510. So 510 is one of the values, and the other says 33k. So this one here, green, brown, that's 5-1 and one more 0, so that's a 510. And this one here, orange, that's 33k. So the values are correct. So let's put these in. I don't think the actual values are very crucial with a multivibrator, but the resistor that goes to the base is meant to be low enough so that it doesn't have the transistor switched on all the time. I mean high enough, so that it's the higher resistance, so it doesn't let much current through. But there's a lot of leeway there, so it wouldn't matter if the values weren't exact. And then these ones here, these are actually load resistors, and so the current going through the LED is limited by these resistors, so this value needs to be reasonably low. I haven't got any data on what voltage this circuit runs off. I'm guessing 5 volts will probably be enough. But we can always experiment with that, because I have a bench power supply. I can set the voltage and current limits. Sure this iron's hot enough. Let's turn it up a bit. Can't remember when this was last used, this one actually, but it looks looks a bit dirty on the tip here. It's not very good. I might get my trusty old Antex soldering iron out, in fact. Okay. It's a bit dark today. Weather's not good. It's raining, a bit thundery outside. So I hope you can see all right with these lights that I've set up. There we are. That's the resistors in place. I think I'll put the capacitors in because I just need to squeeze in between those resistors there. Making sure to get the positive and the negative the correct way around because these are electrolytics. Oh, made a mess of that. It's all connected together in one big blob. Let's just fix one end down. Let's chop these wires back and then try and clean up that. That's all joined together, which is not great, is it? That's all right. I can check it with the meter though. Just make sure these are not still bridged. No, seems all right. Okay. Right, put the LEDs in. I suppose I'll just check the colour of these. Oh, blue. So, a longer leg on the positive side. Probably do with a bit of flux there. The solder's not flowing as well as I might want. But there we go, achieved anyway. although that one looks a bit dry. Okay, so get the transistors in. So the screen print has got this kind of polygon type layout. I mean, some cheap transistors are actually in that shape. They have all flat faces, but these ones are kind of a rounded back. So I probably ought to check the connections before I put it in place. I'm assuming from when I sort of worked out the circuit diagram that the center pin is the base. But obviously crucial to know which one is the emitter and the collector. The collector is going to be closest to, I don't know, let me see. So the LED is connecting to that bottom one. Which should be the collector, and this one's upside down in relation to that one. So let me just check the pinout of these. What are they? S9014. So I remember that's an NPN transistor. Let me look that up. So the left hand side is the emitter. Right, emitter. No, that's absolutely wrong. Must be this way around. So left is the emitter, and the emitter is connecting to a power rail. So yes, I'm going to go with that. And then this one's the other way up. Right, I might solder on these spare wires, so let's clip this end off. I'm going to say that purple is positive. Oh, fiddly wires. Cut off the excess. Alright, so that's all of the components fitted, the wires on, so let's plug in the power supply. Right, set for 13 volts, which is no good. Let's go for 5, I think. And on. There we are. So that's a bit bright for the camera, but you can see it's alternating between the two sides there. So let's have a look at the circuit diagram and I'll explain how that works. So let's see if we can understand this circuit a little bit. So these transistors are acting as switches. So the way that a transistor works is current can flow across here from the collector to the emitter, if a voltage is present here on the base. So a small voltage here will allow you to switch a bigger voltage here. So that's why transistors are useful as amplifiers as well as being switches. But in this case it's just a switch. So when the base is powered on, current will flow through the transistor here, which means that we've got the power coming from the power rail. This was 5 volts, remember, and this is ground down here. So the power will flow through this 500 ohm resistor through the LED, and that's why you get the LED switched on there. And in terms of the timing here, the reason that there's actually a period where the lights flash one then the other is because this capacitor can charge and discharge, and it can charge through this resistor here. So you've got something that they call an RC constant. So when you've got a particular resistance and a particular capacitance, you can multiply them together and it gives you the amount of time that it takes for the capacitor to charge up. So if I wanted to make it flash more slowly, I could change this value. I could increase that value from its current value, which was 2.2 microfarads, wasn't it? So let's assume that this transistor is switched on. So what's happening here now is that because the collector is effectively pulled down to ground, means one end of this capacitor is pulled to ground. So it will then start to charge. So the current is flowing through that resistor, through that capacitor to ground, and it's going to begin to charge up. And if you look at the charging curve of a capacitor, so if this is time here and this is voltage, what happens is the voltage increases to a maximum over a number of seconds, or, well, depending on the value of the capacitor, could be milliseconds or microseconds, but it's going to charge up towards a target figure like that over time. So in this case it starts to charge up, and then eventually we'll reach a magic figure, which is about 0.6 volts for these silicon transistors. And when that level of voltage is achieved, then this transistor starts to conduct. So now this is going to conduct, and because effectively when you first flick on the switch, the voltage on the capacitor is 0. So we're right here at the beginning of the graph here. So we've switched it on, but the voltage is 0. So what that does is it pulls the base here down to 0, and now this transistor will switch off. So now you've kind of gone over to the other side. So now this transistor is conducting, so that LED is switched on, and now on this side you've got this capacitor that's started to charge. So this is basically what it does. The two transistors are helping these capacitors to charge and discharge, and they're also switching each other on and off. So that's the multivibrator. Obviously this is a very simple kit, but quite gratifying to see these old circuits in operation. And thanks for watching. See you in the next video.